1993 has this reaction of butane and oxygen going towards carbon dioxide and water. It says the reaction represented above is spontaneous at 25 degrees Celsius. Assume that all reactants and products are in their standard state, which is at 25 degrees Celsius. So A says predict the sign of delta S for the reaction and justify your prediction. Since we have 15 moles of gas going towards 8 moles of gas, I said the disorder, since gases have more disorder than liquids, the amount of disorder is decreasing, therefore the sign of delta S will be negative because delta S is a measure of disorder. B asks, what is the sign of delta G for the reaction, and how would the sign and magnitude of delta G be affected by an increase in temperature to 50 degrees Celsius? The sign of delta G will be negative because this reaction is spontaneous. So anytime a reaction is spontaneous, the sign of delta G will be negative. When it asks if the sign and magnitude will be affected, the sign may or may not be affected by an increase in temperature depending on the numbers, the values of each delta G, delta H, and delta S. Since those are unknown, we don't know if the sign will be affected. However, we do know that the magnitude of delta G will be decreased by an increase in temperature, because if this variable increases, so will the amount of delta S, and since it is subtracted from delta H, the magnitude of delta G will be a smaller number. C asks what must be the sign of delta H for the reaction at 25 degrees Celsius. And the sign of delta H must be negative at 25 degrees Celsius because both T delta S and delta G will be negative. And if we rewrite this equation to have delta H on this side, so a derivative of that equation would be equal to delta H is equal to delta G plus a T delta S. So if both delta G and T delta S are negative, those are two negative numbers being added together, so a delta H must be negative at 25 degrees Celsius. D asks, when the reactants are placed together in a container, no change is observed even though the reaction is known to be spontaneous. Explain this observation. And my logic for that was even though the reaction is spontaneous, no change is observed because there's not enough energy within the container. It may be a vacuum, may not be, we don't know. But there's not enough energy in the container to activate the reaction.